Okay, this is problem 7 from chapter 4 of CFIN7. Chapter 4 is the time value of money. It's an important chapter because we'll use the time value of money throughout the rest of the semester. This is a future value of a lump sum problem. The future value of a lump sum asks the question, what is a single payment worth at some point in the future given some interest rate? So read the question here. 10 years ago, Manuel and his friend Julio invested $1,000 in two separate investments. Manuel's investment earned 6.6% compounded monthly, whereas Julio's investment earned 6.8% compounded annually. How much is each investment worth today? So we'll start with Julio because that's a simple one. The compounded annually, we just literally enter the information. So we got 10, and then the interest rate is 6.8, so 0.068. And if I come up here, I hit the percent key. Don't have to do this, but easier to visualize when you format it. So minus 1,000 is the present value. That's how much you deposited. 0 is the payment, and then we're going to calculate the future value equals FV, and then open paren. So the Excel actually shows you what you're going to enter here. So my rate, 6.8%. Number of periods is 10 years. Payment is 0. And then my future value. So I don't have to worry about the type here. Type is either 0 or 1. The default is 0, which means the payments are made at the end of the period. There will be a couple of problems that we'll do where there'll be payments are made at the beginning of the period, but you just enter 1. So Manuel's investment is worth $1,930.69 at the end of 10 years. I'm sorry, Julio's. All right, so now Manuel's is compounded monthly, so we need to calculate the number of months. So we're going to multiply 10, the number of years, times 12, and we get 120 months. So now we have to make our rate a monthly rate. So 0.066 divided by 12. So our rate, I do some formatting. So I hit the percent key, add a couple, so the 0.55% per month. So then minus 1,000 and 0, and I actually could, I can actually copy this over, but as well. So just hit Control C, Control V. With and place it right here, and it would actually pick up these cells. So equals FV. So my rate, number of periods, comma, the payment, comma, and PV, present value, and close paren. So $1,931.30. The compounding periods when you're investing are valuable. Compounded periods when you're borrowing are more costly. Your mortgage and car payments are likely to be calculated on a monthly basis. This actually makes the APR higher than not the APR, if the effective rate higher